Okay, well, thank you, Eric. As was noted, my name is Eric Stellwagen. I am a co-founder of Business Forecast Systems. I've also worked in my career, I've worked in the field of forecasting now, as this line says, for about 30 years. Um, Originally, I was working at an engineering company where we did forecasting applications for electric power companies. And then in 1986, I started Business Forecast Systems with a partner, and we developed the Forecast Pro forecasting software. One of the things that I've been able to do over the course of my career is to work with a lot of companies. And this has been great. It's really allowed me to understand how companies approach their forecasting processes, the kinds of things they struggle with. And the variety of companies that I've worked with has been pretty widespread. So I've worked with Fortune 100 companies with tens or hundreds of thousands of employees. I've worked with small 200-person companies that are manufacturing things out in the Midwest. And the similarities, even between these disparate organizations in terms of what they're trying to accomplish, how they're going about it, and what they find difficult is definitely a constant. So let me tell you how we're going to spend our next hour or so. This is a roadmap of how we'll spend our time. We're going to start with some basic concepts about a product hierarchy and approaching, what is a product hierarchy and how do we leverage it for forecasting. We'll spend some time looking at different methods for reconciliation, making sure that we have consistent forecast between the different levels of our hierarchy. We'll talk about some nuts and bolts. How do I go about this? How do we construct a hierarchy? How do we organize our data? What are sort of some of the pros and cons of different approaches? What are some of the pitfalls to avoid? Throughout the webinar, we will be integrating examples. They're all real examples from real-world data from clients, and we'll use them to illustrate the points as we go forward. So let's get started. What you're looking at here is just sort of a sample hierarchy. And when we look at this, I want you to think about the fact that we can organize our data into what I would call different levels. So the example here is from a brewery. The very highest level, we have total sales. Underneath that, we have the different brands that they offer. So perhaps they have a lager style beer and maybe a light beer, maybe an IPA, but those would be different brands. And then there's a question of how do we package the beer? There's retail packaging that would be sold, to consumers. There's commercial packaging that might be sold to bars and restaurants, for instance. These are different markets, and they're handled a little differently in terms of how the brewery forecasts them, and we'll talk about that. Underneath the retail, we have another level here, the packaging type. So in this very simplified example, we have cans and bottles, but there would be many other packaging types as well. And then at the very end, we have the SKU, the stock keeping unit, the lowest level at which they'll be forecasting, which in this simplified example, we have sales in 6-packs for cans, sales in 12-packs for cans. Now, as we talk about the hierarchies, I'm going to make some distinctions between things that are looked at the lowest level at which we'll forecast. I'll call this item level or end item levels, but what I'm trying to convey is the lowest level which we will be generating forecasts for, we're going to refer to as an end item level. Anything above that, if you think about it, is going to be an aggregation, as far as the history is concerned, of the lower level end items. So everything above that is an aggregation. I might refer to it as a group level. So you can see, again, as we look at the hierarchy, we can think of it as consisting of end items and groups. Now, most corporations that are going to deal with a hierarchy like this are going to want forecasts at all the different levels, and usually they're going to want the forecast to be consistent, meaning that if I sum up the forecast for the 6-packs and the 12-packs, that will equal my forecast for the cans And if I sum up the cans and the bottles, that will sum to retail, etc. And one of the things we'll talk about is how we make that consistency, how we do that numerically. And I refer to that as how do we reconcile the forecasts at the different levels so they're consistent. Okay. Now, we have these different levels, and one of the things that we want to think about is how are the forecasts used? And as you look at the different levels, what you'll start to understand is they're often used differently. So at the very lowest level, at the item level, we're talking about SKUs, and we're usually doing very tactical sort of decision making. We're probably planning production, we're planning purchasing, or some other part of the supply chain. We're usually interested in shorter term forecasts. So what am I going to sell over the next 6 weeks, say? Because that's the horizon that is most important for planning the production. So again, we're probably working at a weekly level. We're interested in, say, the next 4 to 6 weeks. As you look up the hierarchy a little bit, let's say you get into that level that we had as retail and commercial. Now we're sort of in the middle. We're probably interested more in things like a monthly forecast, probably for, say, the rest of this year and all of next, so maybe 12 to 18 months kind of horizons. We're making decisions about things like marketing and trying to get a handle on revenue and those types of projections. So it's different than the end item levels, and depending on who's doing the forecasting, marketing and revenue planning may not be at all interested at SKU level forecasts, but they're very interested when we start to get up into the brands or maybe the brands by channel. At the very top, total sales, say, by brand or total sales for the entire brewery. Now we're talking about the big picture. Do we have enough capacity to meet demand going forward? Where are we going to be 3 to 5 years from now? So what, again, in the boardroom, we are looking at forecasts, but we're looking at it at a very high level. We may be more concerned with quarterly or annual. We may be concerned with longer term horizons. If expanding capacity is going to require a couple of years to do it, then those decisions need to be made fairly early on. So again, as we think about the hierarchy, as we think about these different levels, one of the things to keep in mind is that different levels are being used for different purposes. And oftentimes we're looking at the data differently, perhaps again weeks or months or quarters. We're looking at the horizon or the length of forecast going forward differently, all in support of making these decisions. Now, oftentimes if you go to, say, a forecasting conference or you get together with a lot of people who do forecasting, there's discussions about, should a company strive to have one number across the board? Should all the forecasts be reconciled? And those of you who've seen, we had about half the people attending who's attended these webinars before, and if you've seen me give one, then you will know that my stock answer to almost every question is, it depends, okay? Because in forecasting, things get specific very quickly. And oftentimes the answer really is it depends. It depends on the situation. It depends on the company. As the slide says, it depends on the environment. A one-number forecast may be very difficult to achieve. And particularly, although that may sound good in theory, the concept of, say, a long-term strategic forecast in the boardroom really reconciling with, say, a production-oriented forecast, that's simply not going to happen at that level. So one observation I've had is that the larger the company, the harder it is to achieve sort of a one-number approach. Sometimes at a small company, say you really are a relatively modest-sized company, the people doing demand planning may have access directly to the owner or to the CEO, and the scope of what they're doing is such that perhaps they get closer to this kind of one number approach. One thing I will say, though, is that even if we're not going for a one number forecast, communication among the different groups is extremely important. And this is a primary goal of sales and operations planning. And I would say, in particular, this communication between sales and operations in terms of forecasting is important. What you don't want to do is this kind of right hand, left hand, not knowing what each others are doing. So you don't want, say, sales to plan a big promotion, inform operations, say, 4 weeks before the promotion's scheduled to start, only to determine, hey, we're importing some of this from overseas, we can't ramp up that quickly, or if you do it here, perhaps we're going to have a lot of overtime to make it happen. Whereas if we had better communication, then those kinds of discussions occur before things are scheduled. And again, a formalized process like a sales and operations planning process where there's meetings, where there's buy-in from management, where the different functional groups are all represented. This is a very important thing. It can yield huge benefits in terms of having a smooth forecasting and planning process. So at this point in time, we're going to run another little poll here, and Eric Sabatis will put our poll up for us. And the question is, do you currently have a formalized S&OP process? And we've given you 3 options. You can say yes, you can say no, or you can say if you've begun to implement it but it's not in place yet, we can say it's in process. So please go ahead and weigh in. We had about 400 people signed up for the webinar, so there's quite a few people answering the poll questions, and that makes our results pretty meaningful. And let's close up our poll and display our results. Okay, so in terms of a formalized S&OP process, we've got about 56% saying yes, we have one in place. We've got 22 saying no, and we've got a very sizable fraction, 23%, is saying that one's in process. And it wasn't by accident that we included that as an option. A lot of people understand that formalizing an S&OP process will add value, and it really will, but it's not the easiest thing to implement, and it requires, again, coordination between different groups where maybe the corporate culture hasn't traditionally worked together with those groups. It requires strong commitment and buy-in from senior management, which may be difficult to do. But again, an interesting poll result here with a bit over half already using S&OP, and a pretty even split with the remainder between either not doing it or being in the implementing stages. So let's go back to our slides. And at this point, I think what we're going to do is to look at a very simple hierarchy and to sort of make some comments about the different types of considerations that we're going to do as we look at it. So this is, again, about the simplest hierarchy we can do. What I've done is I'm showing you sales of beer. It's on a weekly basis. It is sales in cans, okay? And that cans break down into 2 end items, 6-packs, so that's the sales in 6-packs, and 12-packs, and that's the sales in 12-packs. And let's notice a few things. We're back to total sales in cans. It's a very seasonal data set. That shouldn't be a big surprise. We tend to sell a lot more beer in the summer than we do in the winter. And if you look closely at the data, you might notice that each year we seem to have 3 big summer peaks that are pretty consistent from year to year. And this data comes from the United States, and Americans tend to drink beer, I guess, on three weekends in the summer that correspond to our summer holidays. So we have Memorial Day, we have the 4th of July, our Independence Day, and Labor Day. So you can see the holidays really kind of shining through on this data. The other thing I want to point out is at this level, at the level of cans, the data really are not very trended. They're pretty flat. So this is a well-established brand, and you're not seeing a whole lot of growth on that cans level data. On the other hand, if you look at the 6-packs, there's a definite downward trend here. Okay, so if cans is consistent and 6-packs is going down, 12-packs must be going up. And here are the 12-packs, and indeed, you can see that they have some upward trend. So what we're looking at here, and it's really pretty useful when looking at data at different levels, to really understand it and look at it graphically. And I'm going to put all three of our levels up here. And what you can see is sort of a packaging preference mix, which is changing. So the category, the green line, total sales in cans, again, pretty flat, pretty consistent. On the other hand, the six-packs, which is this blue line, has a downward motion to it, and the crimson, the 12-pack, has an upward one. Okay, and if you're working with data at different levels of aggregation, exploring it graphically can often give you some real insights. The data here, incidentally, if you're going to look at a hierarchy, or if you're going to look at data like this, you need to be careful about the units. It would not make sense for me to show the number of six-packs we sold plus the number of 12-packs we sold, and for that to be the green line. That's sort of nonsense. What I need is a consistent unit of measure so that this graph is meaningful. And in this case, it's gallons, but we could have used liters or consistent cases. Again, depending on the data you're working with, you'll want to arrive upon some sort of a consistent unit of measure so that when we do these kinds of graphs and analysis, that the groups are meaningful. And they certainly are here in gallons. And you can see things like, this region here in about 2013 is where that mix sort of changed over, where the 12-packs actually started outselling the six-packs in terms of volume measured in gallons. So again, graphing the data is often a very useful thing, trying to understand some of the relationships between the different levels. And now let's think about how we'd forecast this. One thing we could do is to forecast at the lowest level. And that's actually the default in this particular package, Forecast Pro. And I'm going to actually do that. I'll just click on this button here. And I can use this green line, the history, to generate a forecast, in this case, for the next year, for the next 52 weeks. And notice that continues the downward trend. It's still very seasonal. We can see our holiday weeks are well represented. And I could do the same thing for 12-packs. And again, we have a little bit of an upward trend. And then the question is, what about cans? And with a bottom-up approach, we simply aggregate the forecasts. So we take the forecast we generated for the six-packs, and we add to it what we forecasted for 12-packs, and that's what equals the cans forecast. A bottom-up approach is a very frequently used approach to reconciling a hierarchy. It's obviously a very simple approach. Is it the best approach? That's a different question, and we're going to address that. And again, those of you who know how I answer every question can anticipate this one. It depends. Okay, there are times where a bottom-up is the best approach. There are times where it's not. So let's talk about that, and let's take a closer look at this sort of idea of bottom-up and top-down and some of the alternatives to bottom-up and top-down. So to illustrate our conversation, we're going to use the same data we just looked at. We're going to think about total sales in cans, as well as our end items, 6-packs and 12-packs, and talk about different methods for reconciliation. So the bottom-up is the one we started with. The concept is very simple. We're going to create what I call model-based forecasts at the lowest level. And by model-based, what I'm trying to convey is that we'll take the historic demand at that lowest level, and we'll use, say, a statistical method to generate an extrapolation or a forecast for it. We will construct any group level forecasts simply by summing the lower level forecasts that are the components of that group. So again, very, very simple idea. An alternative is to go top down. In a top-down approach, let's limit our discussion to our very simple hierarchy with total cans and the two end items. And let me go back to the product for just a second. But now what I'm interested in doing is looking at this total can series and forecasting this. And I'm going to go ahead and do that. I'm going to specify I want to go top down. Okay. And this data is high volume. You probably didn't see a whole lot of change between these two approaches, but the forecast did just change. And in a top-down approach, we take the group level and we forecast it. And that forecast is used, it's retained. And then we go to the lower levels and we actually forecast them as well. But after we forecast them, we adjust them. We adjust them proportionally so that they sum to the top level forecast. And that's called a top-down approach. So again, in a top-down approach, we create the model-based forecast at the top level and by forecasting the aggregated history. And then we create forecasts at the lower levels, and then we adjust the lowest levels proportionally so that they sum to the upper level forecast. I'm going to show you a slide in just a second or two that illustrates exactly how that's done, but the concept is pretty simple. And the main distinction between bottom-up and top-down is that we must feel that we can generate a more accurate forecast at a higher level. And we'll talk more about this, but generally speaking, as you move up a hierarchy, as you go from an end item to a group, or say from a group to a higher group, a couple of things happen. One of them is very obvious, which is you have more volume as you start summing up things. The group level data has more volume than the lower level data. The other thing that can happen, and frequently does, is that you have more structure, that certain patterns become easier to recognize and frankly to forecast. So that as you go up the hierarchy, we get higher volume, more structure, easier to forecast. And so that's the virtue of using a top-down approach, is we can exploit the fact that we have higher volume at the upper levels and that we have often more structure. The last type of allocation that we'll talk about here is what you might call a custom allocation or a proportional allocation. And the idea is at the lowest level, we're not going to forecast at all. We're simply going to use some sort of a known breakout for doing the reconciliation. Now, when would this be appropriate? And the answer here is when things are not changing in time. And this is an important but somewhat subtle point. If something is not changing in time, you don't really need to forecast it. So you need to forecast something when it's changing in time so that you understand how it's changing and how the future will be different than the past. If something's not changing in time, then you can just count it. You don't need to forecast it. So let's think about a couple of examples here. Let's say that I manufacture, say, a computer, and I need a forecast for all the parts that go into the computer. So, you know, the various chips and the keyboard and all sorts of things that go into the computer. What I would have here is a bill of materials. So to build a computer, I've got a bill of materials that tells me exactly how many parts I need and which ones are required. And I would never forecast the demand for parts based on the historic demand for parts. I would simply forecast the demand for the computer and then use my bill of materials to generate the forecast for the parts demand. And so this is an allocation. And it's just saying, you know, the breakout is known, it's not changing in time, so I don't need to forecast at that level. Let's think of another example. How about I work for Nike, the shoe company, and I want to forecast sales of, say, a certain men's running shoe. And I need a forecast for all the different sizes. So in the United States, I'll need a size 9, 9.5, 10, 10.5, etc. I could take the demand for sales of that shoe at all the different sizes and forecast it. And that would be appropriate if the size of the shoe required, if that mix were changing in time. But in actuality, the size of runners' feet is not rapidly changing in time, and I could use a size chart. I basically could take a size chart for men's feet and use that as the way of creating my allocation rather than trying to forecast it statistically. Now, in our example, the proportional allocation is not really a good approach. The sales in six-packs is declining. It's definitely changing in time. and the sales of 12 packs is increasing. So if we were to do a proportional allocation and just say, historically it's been 55% 6 packs and 45% 12 packs, that would be problematic because it wouldn't continue to capture this change. So the allocation can be ruled out for our current example, but might be appropriate for a different example where things are not changing. Okay, so let's take a closer look at how this actually works. And to do so, I'm going to introduce the first concept here, which is what I call on this slide the model-based forecast. And what I'm trying to convey is we have total demand for beer in cans, and if we forecast that based on its own history, let's say that yields a forecast of 120. What if we took the demand for 6 packs and forecasted it? If we did that in isolation, that forecast would be 70. And if we took the history for 12 packs and forecasted it, we'd come up with a forecast of 30. So the model-based is saying if we used the demand histories directly and generated a forecast, here's what we would get. Now notice that it's not reconciled, that if I take that 70 for 6 packs and 30 for 12 packs and sum them, I don't get 120. So the model-based approach certainly can be used, but it's not going to be reconciled. And if we want to reconcile it, we need to use some form of reconciliation. So bottom up, it was the first thing we were looking at. It's a very simple approach. The model-based forecast for the lowest level, in our example, the 6 packs and the 12 packs, is used directly. So the forecast is 70 and 30. On the other hand, the total cans, our group level, is not going to be used. So the 120 that we forecasted there is not going to be used, and instead we simply replace that group level forecast with the sum of the lower items. So again, a bottom-up approach, we forecast at the bottom, we add things together, that gives us our forecast for the total. Very simple, very straightforward. An alternative is to go top-down. So if we go top-down from total cans, that means we forecast demand for total cans, it's 120. That forecast is retained. Then we need to adjust our forecasts of 70 and 30 so that they sum to 120. And we do that proportionally. And I've chosen the numbers to be fairly simple. And if we do that, then 70% of that 120 goes to 6 packs, which yields an 84, and 30% goes to 12 packs, which yields 36. So this is the top-down approach. We actually forecast at all 3 levels so that the model-based numbers are used, but the top level, the 120 in our example, is retained, and the lower levels are proportionally adjusted so that they sum to the top-down approach. In an allocation, what we would do is, again, use the total forecast of 120, but then we'd use, say, a known breakdown like 50-50, or if it's a size chart or a bill of materials, then whatever we have defined there, and we simply allocate that 120 using the defined proportions. So in my very simple example, I've said, let's just make the proportions 50-50, in which case each of them gets 60. So notice in this approach, the total cans forecast is used, the 6 packs and 12 packs is not. Okay. So again, no rocket science going on here. These are all very simple ideas and approaches. Numerically, they're pretty easy to implement and to calculate, but they can make a big difference in terms of the forecast. So an obvious question here, and before we show a slide on it, I'll just comment on the text at the bottom. When we're dealing with a more involved hierarchy, then usually we're into some combination of top-down and bottom-up. Okay, so we don't really work at the very top. We'll probably be working somewhere in the middle. Some people call this a middle-out approach. I usually call it top-down, but you specify from what level you're going top-down. But middle-out is also a phrase that you may hear, and that's what it's referring to. So how do we choose a reconciliation approach? As I stated previously, as we aggregate data, as we move up the hierarchy, we get higher volume, and often more structure. And this argues for top-down. So again, the advantage of top-down is we can exploit higher volume, more structure, easier to forecast. On the other hand, what if to group level, at a certain group level, the items or the groups exhibit distinctly different behaviors? Okay, so it's kind of an apples and orange question. If things are very different, you don't want to add them together and forecast them as a group. You want to forecast them separately. The fact that they're different says that we should use a different statistical model to generate a forecast. And so when we have distinctly different behaviors, this argues for using a bottom-up. As we mentioned before, if relationships between the levels are not changing, this argues for some sort of custom allocation or a proportional allocation, as the case may be. So this is, again, when we think about how we're going to reconcile our forecast, these are the things that we want to be considering. Now, let's look at our beer hierarchy again and think about how this might work. One of the things that I always tell people is that when you're thinking about your data, try to think like your consumers. Try to think like the people who are actually creating the demand. How do they look at the data? And this can actually be hard. It requires that you step away, take a couple of steps back from your data and think about how others look at what you're selling. So if I'm thinking like a consumer, let's say that I go into, in my part of the world, I have to go into a liquor store to buy beer. So I'm going to go into a liquor store and I'm going to buy a 12-pack of my favorite beer. Before I go into the store, I pretty much know what I'm going to get. This is a purchase that I have made before. I know what brand I like. I'm looking for a 12-pack. And even when I go in the store, I know where it's going to be. Okay, so again, this is important stuff because I'm the consumer, I'm making the demand. And before I go into the store, I have a preconceived notion of what I'm going to leave that store with. Now, let's say I get into the store and they're out of 12 packs. What am I going to do? Well, I'll buy 2 6-packs. Okay? To me, the consumer, the one making the demand, these are pretty much interchangeable. If I leave with 2 6-packs or 1 12-pack, I still am leaving with the store with 12 bottles of beer. So yes, in terms of working at the brewery, these are 2 different SKUs. They needed to be forecasted separately, and that's all true. On the other hand, to the consumer, they're pretty interchangeable. They're certainly very similar, and I have no problem thinking that I can combine these, that they're similar enough to combine them and work up at a higher level. So I probably would not go bottom up in this case. Again, because of the similarities, I can exploit a top-down approach and go to a higher level. At the cans and the bottles level, things are also pretty similar. It's going to react to holidays and the weather and advertising and all that kind of stuff in a pretty similar fashion. And I'm pretty comfortable going up to, say, the retail level. On the other hand, I'm not comfortable going all the way up to the brand because that would put together the retail and the commercial. And these are very different things. The commercial sales are, again, say to bars and restaurants. They're advertised differently, they're promoted differently, they respond to holidays differently, they're priced differently. They're too different to go all the way to the brand level. So in this example, trying to think like the consumer, trying to understand the people that are actually creating the demand, I might be led to going top down, say from retail, and maybe even top down from commercial as well. But I wouldn't go any higher than that. And I probably wouldn't go bottom up, okay? So this is the kind of exercise, the kind of thought process that you want to go through when trying to determine an approach to reconciling the hierarchy. So what are the things we think about? Well, step 1, should I consider using proportional allocation? Is it something where, say, a size chart might be used or a bill of materials? And if so, I don't want to be forecasting it. Try to think like your consumers. How do they look at the data? Just because your company is assigned an SKU number doesn't mean that the customer thinks of this as a completely different item. And items that are similar. What are we trying to forecast? Are the seasonal patterns going to be similar? Are the trends going to be similar? Again, let's try to think like our consumers and understand how they're looking at things. At times, we may be forced into not using bottom-up, and we'll see an example of this shortly. But there are times where the data simply don't support forecasting at the lowest level, and in those cases, we may have to take a different approach. Okay, so let's now, another approach here on the slide is if we're unsure, we can always try it different ways. So perhaps we try a top-down approach, we try a bottom-up approach, maybe we do a holdout sample, so we measure the error, and we see which one works best empirically. And that's certainly a reasonable approach when we're unsure from the data itself. And as I mentioned before, most multiple level approaches are going to use some combination of top-down and bottom-up. And certainly in our beer example, that is the case. Okay, now let's talk about some nuts and bolts. What's the work involved when I'm running a hierarchy? What kind of decisions, when I'm forecasting a hierarchy, what kind of decisions am I going to need to make? Okay, we've mentioned this first one before, but we have to be careful with the units. We have to make sure that it makes sense to be adding these things together. So we need some sort of comparable units of measure to have the group level data be meaningful. Here's a big one. The hierarchy should be as simple as possible and still get the job done. I can't tell you how many complex hierarchies I've seen that include levels that are not necessary for forecasting, but that people want to look at. And if you want to look at something, you don't necessarily need to include it in your forecasting hierarchy. Another thing I've seen, I've gone into clients where they've just purchased, say, Forecast Pro, and you come in and they show you the data, and it goes all the way, say, down to the customer level by SKU. And at the customer level by SKU, the data is just so low volume and very hard to forecast and very hard to work with. And I've had these discussions multiple times where you say, why are you trying to do it at a customer level? Do you need to have it at the customer level? And the answer is no, we don't actually need it at the customer level, but it was easy to put it in the software, and we thought it'd be kind of fun to look at it that way, and that's why we did it. So the old process didn't forecast at the customer level, but because now they've perhaps purchased some software where it's easy to bring it in a higher level of detail, they feel like that's a good thing to do. Refrain from this, okay? Forecasting is a discipline where the KISS principle, keep it simple, it really should be followed. If I don't need a level in the hierarchy to make the decisions I need to make, don't include it. Anytime we increase complexity, we're just making our work harder. We're generally going to make our forecast less accurate. And this is something where if management says, I want to see this at a super fine grain level of detail, you really want to think, do we need it at that level? And if it's not needed for decision making, then we really want to push back. And that may be politically difficult, but in terms of building a strong forecasting process, this keep it simple, really you should strive for at all times. Now, just out of curiosity, we're going to run another little poll here. And the poll question, Eric's going to bring it up for us. And the question is, how many levels are in your forecasting hierarchy? Or, as you're looking at the data you're forecasting, how many different levels do you tend to be looking at? You can see we've got a whole bunch of choices there. I'll be interested to see what we come back with. The results are coming in, and we'll give you a few more seconds here. How about 3, 2, 1? And let's close up the poll, and let's look at our results. Okay, and this is pretty good, actually. Or maybe people are just ashamed for the big hierarchy ones to let us know. But we have most of the respondents seem to fall into 4 to 6 is the most popular category, followed pretty closely by 2 to 3. And that's great, okay? Working with 2 or 3 is wonderful because, again, it's simple. 4 to 6, yeah, we see a lot of hierarchies that are sort of 4 to 6 levels. When you get beyond that, take a hard look at that. You know, if you're doing 7 to 12 or over 13, can we simplify this? Because it's very likely to make things easier. It'll streamline our review process. And it would probably make the forecast more accurate, particularly if we can get rid of our lowest level. And that's the real key here, is if at the lowest level we're forecasting, if that's not strictly needed, don't include it. So again, let's take a hard look at that as individuals and ask ourselves, can we make something simpler? Let's go back to our slides here. Okay, and continue with some of the nuts and bolts of doing this. Okay, discontinued items. This is important, actually. So we have a product hierarchy. It includes all of our active products. What about the ones that we had in the past that have been discontinued and replaced? Okay, so oftentimes we're going to need to include the history for our discontinued items, because when we look at a group level, we need to know what the demand was for that group, even though the components of that group change over time. So if we're going to go top down, remember, we're going to use the history at the group level to generate a forecast. And that means we actually need the history at that group level. And that may be composed of both active and inactive items. And so you'll need to take this into account. And I've seen people not do that and get themselves into some trouble. Okay. The last one on this slide here says that the structure of the hierarchy should be selected for forecasting, not for reporting. Boy, this is a big one, okay? I can tell you I've seen this many times. So what am I referring to here? I'll use a slide to help illustrate this, and we'll actually look at an example as well. This is a hierarchy I put together for a telephone company a while ago. And they have total business. It breaks down to sort of the class of service. So we got business and residential and public. And then it breaks down, the class of service breaks down to some of their other offerings. And then this particular phone company offers service for multiple states. Okay, so it's in the Midwest and it has several different states where the service territory extends. And so you can see at the lowest level, I put the states. So that's one option for this hierarchy. On the other hand, I could have set the exact same data up like this. So here I take the total demand and I immediately break it down to the state. And then I break the state down into business and residential and public. And then I break that down into what's available at the lowest level. Now, if we really think about this, what you're going to realize is at the lowest level of both of these hierarchies, there is a one-to-one correspondence. In other words, this, state 1, main, business, is right here. It's main, business, state 1. State 2, main, business, would be hanging off of here somewhere. We haven't drawn the whole hierarchy. But the main concept is there's going to be a one-to-one correspondence at the end items. So what we're really looking at is two different ways of defining a hierarchy for the same data. Okay? Now, I asked the phone company, we could set it up this way, we could set it up this way. How should we set it up for forecasting? And almost everyone in the room immediately said, use the blue one, okay? The one where we break down to the states. And I said, why? And they said, because we need a forecast at the state level. And this was the wrong answer. This is not the answer I was looking for. So what they're violating here is this question of how should I set something up for forecasting versus how should I set it up for reporting? Those are two very different things. Now, in terms of forecasting, I can do things with the red hierarchy that I cannot do with the blue hierarchy, and vice versa. In speaking with them and dealing with telecom companies, one of the things that's very clear is that business, residential, and public are three very different things, and you really can't work in terms of going top down above that class of service level. So what does that mean? It means that the highest I would go in the red hierarchy would be this class of service level. Let's call it level 2 since it's the second level down. On the other hand, the highest I'd go on the blue hierarchy would be the third level down. The red hierarchy allows me to aggregate up across the states. So total business services would include all the different state 1, state 2, etc. I can't do that in the blue hierarchy. In the blue hierarchy, I'm going to be working, again, probably at this level, and I can't aggregate the states. So the question becomes, is it useful to aggregate the states? And the answer is going to be, as always, it depends. If the states are very similar, and in this case it was, so that basically, you know, what's offered in each state is the same, the television advertising goes across the states, the pricing is the same, etc. And it really, the red hierarchy was the way to go because it allowed us to aggregate the states, achieve the higher volume and more structure that was available. So even though they have to report it state by state, they really should organize it for forecasting using the red hierarchy. And this was very counterintuitive to them, and it was this problem of, again, confounding this reporting requirements with forecasting. If I can get a better forecast with the red hierarchy, that's what I want to do. After I've done it, I can report it any way I want. I could throw the results into Excel and put it into a pivot table and show do a report for total sales by state. If I'm using Forecast Pro or some other software that has an integrated database, I can look at it differently. But again, I don't want to confuse the data, forecasting the data with reporting the data. So here's just very quickly, here is the data. You know, we had total sales, and that broke down to residential and business and public. And the next level down was by type of service. And the lowest level, we have the different states. Okay, so the different territories, the different states and the territories. I forecast it using this, and notice I've gone top down from class of service. And now after I've done that, and let me go ahead and expand the hierarchy just so you get a feel for this. So I'm gone top down from class of service, and I've used the power of being able to aggregate all of the different states. Now I need to report it. Okay, what do I want to do? Well, basically, I want to move that state 1, or all these states, up the hierarchy. I want to reorder this hierarchy. And that's just a database job. So what I'm going to do is I'm going to move what I'll call, say, level 4, and I'm going to move it up to the class of service level. Okay, hit OK. And I've reordered the hierarchy. I have not reforecasted it, but now I can simply look at this and say, here's total sales for the state, and there's my numbers, and if I want to adjust them, I can. And if I want to drill down now, I can look at the different types of service and the different offerings. But the main thing here is I didn't reforecast this based on the new hierarchy. I simply took the forecasts we generated and rearranged them so that I could view things by state. Okay, so again, let's go back to our slides here. The point that we're trying to emphasize, and again, a very common mistake, is this last bullet. The structure of the hierarchy should be selected for forecasting, not for reporting. Okay, so let's continue on. We're coming towards the end of our presentation. And what I'm going to do now is to run through an example that sort of brings everything together. I really like this example because it really illustrates the difference between, say, a top-down and a bottom-up approach. The data represents sales of over-the-counter cold remedies. The comparable unit, everything is actually measured in pallets. This is a company that manufactures products in the United States, but we're looking at sales or demand for Mexico. So the products are manufactured in the United States and shipped to Mexico, and the question is, how many pallets of cough syrup, how many pallets of inhalers and gel caps and other over-the-counter cold remedies. The main data here is the syrups. It's the majority of their sales, and you can see it's a very seasonal series. We've got 3 or 4 years worth of data. Some of the other products, like the inhalers, very different behaviors. Okay, notice the patterns really are distinctly different between, say, these gel caps and the cough syrup. The cough syrup breaks down to an original flavor and an alternative, and the original breaks down to the SKUs. Now here's something to look at. This is a sales in a certain size bottle, okay, of original flavored cough syrup. It's very rough. In other words, forecasting this, it has a lot of randomness to it, and yet it's part of the syrups. And the syrups are not so rough. And this is what I was talking about before. As you aggregate, you get higher volume, more structure, easier to forecast. And as we look at the SKU level, you know, this is much rougher data, much harder to work with. The ones that are gray are items that have been discontinued. So we're going to include them because they need to go into the totals. Okay, and we can look at a couple of these. Let's put them up on the graph here. So you can see, you know, here's the total sales of cough syrup. Here's an individual SKU that was discontinued. Here's another one that was discontinued. Here's a very low volume one that was discontinued. These are the active ones. This company, these are their most important products. These are the ones they really want to get right. And they're all very short. Here's one that only has 2 months, and one of them 0. Okay? Now, and let's look at this graphically as well. So let's put a couple of these active ones up here. Okay, and you can start to see the problem here. If I want to forecast based on this history, that's going to be pretty tough. We have less than a year's worth of history here, and it's going to be hard to get a good statistical forecast. So bottom up is not likely to work very well. Okay, but let's do it anyways. I'm going to go ahead and generate a forecast using a bottom up approach. Here it is. And it's the kind of forecast where you could give that to your manager and be immediately fired. Okay, so you don't want to do that. It's pretty much a flat line. Why? Because we didn't forecast at this level. We forecasted at the SKU level. And because the data were so short, we got a lot of flat lines. Some of the flavored ones have a little longer history and not necessarily flat line forecasts. But if you add up a bunch of flat lines, you're going to get a flat line. And so when we get up to the syrup level, it's just, we're too low on the hierarchy. We didn't have enough data length. We didn't have enough structure to get at the seasonal pattern, which is pretty apparent at this level. If we go top down, let's try that. You can see a much better forecast. Now we are forecasting at this level, and we can get at that seasonal pattern. Furthermore, as we look at the lowest level, rather than that flat line forecast, we get at some of the kind of variation that was readily apparent at the higher levels. So are these great forecasts at the SKU level? No, they're based on very short data, but they are much better than the flat lines that were generated with the bottom-up approach. And certainly at the group level, we're looking at a dramatically improved forecast. So I like this example because it really illustrates the difference between the two. Now, what about the fact, do I think that top-down for syrups, is that correct? And let's do one more thought exercise here. I'm a consumer. I'm going to go into the pharmacy. I'm going to buy some cough syrup. This is a very different purchase for me than selling or buying beer. When I went in to buy beer, I pretty much knew before I entered the store exactly what I wanted. What do I think about when I go in to buy cough syrup? Well, I don't do this very often, so my mind sort of says, I want a medium-sized bottle. You know, I want a bottle that's maybe 4 inches tall. I don't want a big bottle. I don't want a particularly small bottle. If I go in there and I look on the shelf, well, it so happens that this manufacturer has 5 active SKUs for original flavor and 4 for this alternative flavor, but I don't know that. And if the pharmacy doesn't have all of them, I'm not going to know that either. I'm just going there, I'm looking at the shelf, I'm seeing what's there. Trying to say, I want a 4-inch high bottle. Is that a 400 milliliter? Is it a 350? I don't know. It's a very different kind of purchase, but it does say that it's very logical to be lumping these together, because to me, they're the same. They're just different sizes of the same product. So I'm very comfortable going top down from syrups. I would never go top down from total, because then I'm saying, I'm going to lump in cough syrups with gel caps, and very different behaviors. And if they're out of cough syrup, I'm not going to buy gel caps or an inhaler. Okay, so it's very clear to me that the right level to forecast would, in this case, for the cough syrup, would be at the total syrup level. And that's great, because if I try to work at the lowest level, well, we've seen that simply didn't work. So again, I like the example because it really does show a distinct and dramatic difference between a top-down and a bottom-up approach. So let's wrap up, and then we'll take some questions. Many organizations are forecasting a hierarchy. And when we're doing it, and the theme of this webinar has really been, how do we get consistent forecasts across different levels, and how do we strive to make them the most accurate that they can be? Defining the hierarchy is important, and there are decisions to be made. We need comparable units. We need to worry about discontinued items. We need to figure out how the hierarchy should be organized. And again, we want to keep it simple, and we'll make that as simple as possible and still get the job done. If we don't need a level, don't use it. And if we don't need it, particularly at the bottom level, don't use it. So keep things simple, keep things comparable, and try to make our life a bit easier. How do we reconcile? Again, top-down, bottom-up, proportional allocation. These are the tools of the trade here. Try to think like our consumers. Try to understand how the demand is being generated. Keep in mind that if we can go top-down, that takes advantage of higher volume, more structure, easier to forecast. That's a good thing. On the other hand, if we go too high and start putting in things with distinctly different behaviors and aggregating them, then that argues that it shouldn't be done. Again, because different behaviors require different models, we don't want to go top down too high in our hierarchy. Usually we're going to work somewhere in the middle. And of course, we also want to think about, does it actually need to be forecasted? Or can we use some sort of an allocation scheme for something that's not changing in time? Okay, so that's really the part of the webinar, or that's the conclusion of the formal presentation of the webinar. What I'm going to do now is show just a couple little slides on some forecasting resources that we have, and then we'll open it up for a few questions. This is a quarterly webinar series. Again, about more than half of you have seen previous webinars in this series. I want to point out our next webinar is going to be on the ins and outs of exponential smoothing. I actually will be presenting that webinar as well. Exponential smoothing is an extremely popular forecasting method, and an extremely important one. For many applications, it is often, or for many types of data, it can be the method of choice. It also, because it can be automated, is found in a lot of automated forecasting systems. During the webinar, I'm going to conceptually explain how the method works, and we'll be looking at the different forms of exponential smoothing and illustrating how to apply them. We're also going to look at a new type of exponential smoothing, which Business Forecast Systems pioneered recently and added to Forecast Pro. The name is a little technical. It's called an NA, which is not trended, additive seasonal pattern, constant level exponential smoothing model. But, and we may think up a more sexy name for it at some point. But basically, this is a model that works well when the sales are sort of, for data that you might have what you call a selling season, when there are times of the year with very high sales and other times of the year where sales are, say, zero or low. So think like if I'm selling automobile tires and I have some snow tires, I'm going to do the vast majority of my business in the winter. And during the summer months, we might occasionally sell some snow tires, but not very many. So that'd be an example of the type of data where this might work well. Or say something like industrial pesticides, something like a crop treatment or something like that, where there's only certain times of the year where these things would be used. But again, I'd encourage you to attend the next webinar. If you visit forecastpro.com, there is a registration form set up there. You can just click through and sign up. And then, of course, you'll get reminders as it gets closer. It is free, so there's no downside. I'd encourage you to go ahead and sign up, and we'll send you reminders as it gets closer. The other thing I wanted to mention before the questions is we are going to be running a user conference at the end of September. It's going to be held in Boston. It consists of 3 days, and we're pretty excited about it. It should be a really good conference. The first day is a pre-conference workshop. We're going to spend the day looking at different forecasting methods and understand how they work and how to implement them. So actually similar to the kinds of things we do on the webinars, but it'll be a real informative and packed day where we're going to go through all the methods that are implemented in Forecast Pro and teach you how to use them effectively. Tuesday and Wednesday is the main conference. We are limiting attendance to 60, and the idea is we really want a lot of interaction. We want to be able to have a lot of networking, a lot of discussion, a lot of questions and answers, and really have everybody kind of leave there having met everybody and had a chance to really discuss their forecasting processes. We have a lot of information on forecastpro.com. You can click through to the user conference site where we've got the whole agenda and some detailed information there. So I encourage you to, if you're interested in that, to take a look at it. The kinds of sessions that we'll be running, here's a sampling, but again, the website will have more detailed. There will be a fair amount of emphasis on the Forecast Pro Track product. We'll look at things for you track users out there. You probably know that the override grid is a pretty complex beast. But it allows you to do a whole lot of good things, and we're going to have a presentation on how to optimize that and work with it. Things like improving Forecast Pro's performance. We have a session on continuous improvement where we're really looking at how do I improve my forecasting process every step of the way. We'll have case studies, including one from Caterpillar on how they've implemented Forecast Pro across their dealer network. So they've got numerous dealers that they've been using it, and we've got a very really expert both in terms of forecasting and in terms of implementing and getting buy-in across a big organization. Our speaker is Pat Deshawn, and very, very knowledgeable, and I'm sure it'll be a great session. So, and there's a lot of other sessions as well, but I'd encourage you, if you are interested, to visit forecastpro.com and learn more. For those of you who are not familiar with Forecast Pro, all of the examples that we were doing in the webinar today used Forecast Pro. Obviously, if you'd like to learn more about Forecast Pro, we'd love to help you out. The best way to learn more is to get a free live WebEx demo. If you want, in the chat window, if you want to just send us your name, we can contact you and arrange that. Alternatively, if you want to visit forecastpro.com, there's a lot of information there. There's also some videos as well. And again, if you're interested in learning more about the software, let us know and we will definitely help you out. So we have run a few minutes late, but I think we have time for just a couple of questions probably.
Yeah, we have a couple of questions. So we'll start with this one, kind of S&OP oriented. I have a hard time convincing marketing to make contributions to or even join my S&OP meetings because they think mostly at a product family level, whereas I think about the data at a SKU level. How might I reconcile this?
Okay, so good question. And what we're really talking about here, I think one of the things that's important when you are looking at S&OP, it's not so much that we want to change marketing so that they're thinking at a SKU level. It's more we want their input at the level where it's relevant. So, if the information they can provide at the levels they're working with can be important to us as we're planning SKUs, even if they're not really willing to engage at the SKU level. So the fact that they may be promoting at a group level, They may be, again, have information about expected demand at a group level. I would say it'd be nice if we can try to educate them, particularly S&OP is a long-term initiative, and as it continues to evolve, if they can get a better awareness of the overall picture. But I think I would take the attitude of, let's try to get them to contribute at the levels at which they're knowledgeable, and then perhaps, unfortunately, it's up to us to do some of the how does that translate to changes at, say, a more detailed SKU level or what have you.
Okay, and we'll do one more question. There were some other good ones, some of them Forecast Pro specific. So like I said at the beginning, we'll be in touch either today or tomorrow to go through those with you. But we'll leave off on this one. This one's a little bit more general but important. Can you comment on how I might simplify a hierarchy while also permitting critical drill downs? Or to take it a step further, can you give an example of how I can decide which levels are critical to include and which levels might not be?
Okay, excellent question. Again, plays back a little bit to one of the things I mentioned, which was a difference between reporting and forecasting. So let's go back to, let me pop a slide up there where we show that hierarchy. Oops, my presentation mode doesn't like that, so I'm just going to put it up like that. So yeah, again, so the question is, there's a question of being able to generate a most accurate forecast and to make that hierarchy as simple as possible and still be able to do that. Then there's a question of generating reports, looking at the data, and manipulating the data at different levels. And one of the things that Forecast Pro supports and many others does as well is the ability to define things like filters, so that I can forecast with a very simple hierarchy, but then I could maybe group using things that we're not generating with the forecast. So, for example, if we look at this hierarchy, it's pretty simplified, and there are 5 levels to it. It doesn't have things like customers or salespeople or other things, but I might have information on that and be able to generate reports. So again, it wasn't necessary to have that level to generate a forecast, but by keeping in mind the difference between forecasting, reviewing and reporting, and doing things like adjustments, that's the kind of stuff you want to strive for. Let's make the hierarchy as simple as possible, generate the best forecast we can, then let's think about reporting as a different function. So that would be my advice there. Okay, again, we ran a little late, but hopefully you've learned a few things through the presentation. As Eric Sabatis mentioned, if you do have any, if you've submitted questions that did not get answered, then we'd be happy to, we will be following up with you in terms of by email to answer them. And if you are interested in learning more about Forecast Pro or any of the other offerings from Business Forecast Systems, then by all means, please contact us, and we'd be very happy to talk to you about it. So thank you all for your time, and I hope to see you, quote unquote, at our next webinar, which will be on exponential smoothing. So thanks again, and enjoy the rest of your day.